All right, today we're diving right into the heart of the industrial Internet of Things, the IIoT. We're going to tackle the big debate, the one that's shaping how all that heavy machinery actually talks to each other. MQTT Sparkplug versus OPC UA. Let's get right to it.
So, have you ever stopped to think about that? I mean, really think about it. You've got millions of devices, sensors, actuators, giant robots, all from different companies, built in different decades. How on earth do you get them all to speak the same language? Well, that's the exact problem that these two protocols, MQTT Sparkplug and OPC UA, were built to solve.
You know, for the longest time, the factory floor was basically the Tower of Babel. Every piece of equipment had its own proprietary, locked-down language. Trying to get them to work together was a nightmare. It created these huge data islands and just, well, a ton of inefficiency. The industry was screaming for a universal translator.
And the first real attempt at this came way back in '96 with something called OPC Classic. Now, the goal was fantastic: create one standard way for all the hardware and software to talk. But, and this is a big but, it had a fatal flaw. It was completely handcuffed to Microsoft Windows and its DCOM technology.
Yeah, being chained to one single operating system was a massive roadblock. The world was moving on, towards different platforms, bigger scale, better security. OPC Classic just couldn't hang. It was crystal clear that a totally new, more open approach was needed.
So, in 2006, the OPC Foundation came back with OPC Unified Architecture, or as everyone calls it, OPC UA. And this wasn't just some patch or an update. No, this was a complete teardown and rebuild from scratch. You should think of OPC UA as the architect. It's meticulously designing this incredibly robust, structured, and secure universe for all that industrial data to live in. So how does it work? Well, at its core, OPC UA runs on a very traditional client-server model. A client, say your control system, has to specifically ask a server, like a sensor, for a piece of data. The analogy here is perfect. It's like you're sitting in a restaurant. You get the menu and you order exactly the dish you want. It's a direct point-to-point request. Simple as that. Okay, but while OPC UA was busy building its grand, structured universe, a totally different philosophy was bubbling up from a completely different set of needs. And that brings us to MQTT. I like to call it the messenger. Why? Because it was born out of a need for pure, lightweight speed and efficiency, especially when conditions are tough. MQTT's story is really cool. It started in the late 90s, believe it or not, from monitoring oil pipelines over satellite networks that had next to no bandwidths, so it had to be incredibly light. Fast forward to 2010, it gets released as an open standard, and boom, it just explodes in popularity, which eventually led to the really powerful MQTT 5.0 that we have today. Now, this right here is the fundamental difference. MQTT doesn't do client-server. It uses a publish-subscribe model. So instead of asking for data, a device just publishes its data to a central hub, called a broker. Think of it like a newsstand. Then, any other device that cares about that data just subscribes to that specific topic. It's exactly like a magazine subscription. The new issues just show up at your door automatically. It's a one-to-many approach, and it's a total game changer.
But of course, the story doesn't end there. Neither of these protocols just sat still. The industrial world has some really unique, demanding requirements, so both MQTT and OPC UA had to evolve. And this is where things get really interesting.
So check this out. On one side, MQTT got a massive upgrade called Sparkplug. What Sparkplug did was add a standard data format and something called state awareness. It basically taught the super-fast messenger how to speak a structured industrial language. Meanwhile, the OPC UA folks looked over and said, hey, that MQTT delivery system is pretty slick. So they created OPC UA over MQTT, which lets them put their rich architectural data on top of MQTT's super efficient messenger service. The lines started to blur.
Okay, so now that we know the players and how they've evolved, let's put them in the ring, head-to-head. First round, performance and payload. How do they actually move the data around?
This table really cuts right to the chase, doesn't it? MQTT Sparkplug, with its pub-sub model, is all about efficiency. We're talking minimal overhead. Its payloads, the actual data packets, are super lightweight. It's built for speed. OPC UA, on the other hand, is built for depth and complexity. That client-server model and its complex data structures mean it needs more bandwidth, but in return, it can carry way more context and structure within a single message. Next up, let's zoom out and look at the bigger picture. Let's talk architecture and, importantly, scale. How well do these protocols handle growing from, say, 10 devices to 10 million?
And here's where you see the trade-offs so clearly. When it comes to interoperability, OPC UA is the undisputed king. It natively supports over 60 different data types. It's incredibly robust. But when it comes to raw scalability, MQTT Sparkplug is the champ, hands down. It can handle millions of messages per second. Now, both have state awareness, which is just a fancy way of saying they know if a device is online or has suddenly dropped off. But they get there through very different architectural philosophies.
And for our final round, we've got to talk about two of the most critical factors for any industrial system: security, and frankly, how much of a headache it is to get the whole thing up and running.
This really brings it all home. OPC UA is like Fort Knox. Security is baked into its DNA. We're talking certificates, encryption, digital signatures, the whole 9 yards. But all that robustness comes at a price. It's just more complex to set up and configure. MQTT Sparkplug, on the other hand, is way simpler to get going with, often with just minimal configuration. But its security features aren't nearly as comprehensive right out of the box.
So, after all of that, we land on the million-dollar question. With all these pros and cons, all these trade-offs, how do you possibly choose? Which one of these is actually the right fit for what you need to do? Well, the takeaway is actually pretty straightforward. If you're dealing with shaky, low-bandwidth networks, or you have a massive number of sensors to connect, or if every single byte of data matters, then MQTT Sparkplug is almost certainly your best bet. But if you're on a fast, secure, reliable network and you need really complex machine-to-machine conversations with a deep, standardized information model, then OPC UA is the architect you're looking for.
And you should make no mistake, this debate is far from over. As this quote from our source material at EMQ puts it, the competition and the evolution of these two powerhouses is still happening right now. And it's what's driving all the innovation in this space.
Which kind of brings us to our final thought. With things like OPC UA over MQTT becoming a reality, we're seeing these two worlds start to blend together. And it leaves us with a really fascinating question to ponder. Is the future of industrial communication really about picking one winner? Or is it about a powerful collaboration where we get to take the absolute best of both worlds? Something to think about. Thanks for tuning in.